Hey guys, welcome back to chapter 3. We are entering the second half of this chapter where we're going to build on what we know about electrons and talk a little bit more about how these apply to everyday scenarios. So eventually what we'll be able to predict is some of the periodic properties. So what we know about the periodic table is that it is in fact periodic. Every 8 elements or so, we see patterns are repeated. So this is our journey to starting to understand and explain those periodic properties. In the last chapter, the first half of this chapter, we talked about where electrons reside. So we talked about the fact that we have our nucleus in the center of our atom, and then organized around that is where our electrons reside. And they reside in things called orbitals. So we looked at quantum numbers, we looked at the zip code to finding those electrons. What we're going to talk about in this video is we're going to talk about how the electrons get there. They actually don't get free choice, like I want to live in the third energy level in a d orbital. There's actually a very systematic way in which they file into these orbitals. So that's what we're going to talk about today. So here we see what's called an orbital diagram. An orbital diagram shows us how the electrons file into these particular orbitals. So if we look at this orbital diagram over here, something that's at the bottom of this diagram is going to be very low in energy. Something at the top of this diagram is going to be high in energy. So when these electrons file in, they will fill orbitals at the lowest energy available. And then once that's full, they'll go to the next one, and to the next one, to the next one, so on and so forth. So we fill the lowest energy level first, and then we continue to progress up. Okay. Each of these lines, and in the next slide, there will be boxes. Each of these lines represents an orbital. So down here, we see our 1s orbital. That's going to be that spherical orbital in the first energy level. In each orbital, we can put up to 2 electrons. And the way that we depict that is we use half arrows. So 1 electron going into the orbital would be depicted as a half arrow pointing up. The second electron going into the orbital would be depicted as a half arrow pointing down. So this orbital is now full. It has 2 electrons. So then I would go to the next orbital, and I would start putting electrons in there. And that process would continue. Okay. This idea of electrons filling orbitals from the lowest energy to the highest is called the Aufbau principle. So Aufbau is a German word for meaning to build up. So we build up, or we put electrons from the bottom to the top. Okay. Here we see another depiction of an orbital diagram. It depicts the same thing as this one. It's just a little cleaner, easier to see. So that's why I chose this one. Let's take a look at an example. So the example that we're going to look at is lithium. So before we can look at lithium and how electrons file in, we need to first know how many electrons are in lithium to begin with. So if you don't have one in front of you, go ahead and grab a periodic table. So looking at the periodic table, I see that lithium is the 3rd element. That number at the top tells us how many protons are in lithium. It also tells us how many electrons are there. So for right now, we're going to assume that these atoms are neutral, that they have the same number of protons and electrons. So if lithium has 3 protons, it also has 3 electrons. Okay. So now we've clearly defined how many electrons are in lithium. Let's see how those 3 electrons would file into place. So the first electron is going to go on the lowest energy level available, which is the 1s energy level. So I'm going to put 1 electron in there. The second electron is also going to go into the 1s, so they hold up to 2 electrons, so we're going to fill that one up before we move on to the next one. The next energy level and orbital that we see is the 2s orbital. So we're going to put our third and final electron into the 2s orbital. So this would be the orbital diagram for lithium. Okay. Let's see if you guys can do the orbital diagram for boron. So determine how many electrons are there, and then put those electrons into place. All right, boron has 5 electrons. So again, the first 2 electrons are going to go into that 1s orbital. So 1, 2, that is full. We go up. I'm going to add 2 more, 3, 4. That is full. I have 1 more electron that I need to find a home for. So I'm going to go to the 2p orbital, and I'm going to add that last electron there. Let's do another example. So the next one we're going to do is nitrogen. So go ahead and pause the video and see if you can do the orbital diagram for nitrogen. All right, so nitrogen has 7 electrons. So first 2 are going to go into 1s, so 1, 2, then we go to 2s, 3, 4, then we go to 2p. I'm going to bet that a lot of you guys did this. So 4, 5, 6, 7. That is not entirely correct. Okay. So looking at putting these electrons into these orbitals, what's going to happen is the electrons will actually go into their very own orbital without pairing up if that's an option. So let's think about an analogy here. Let's think you're going on to a 4-year university, right? You're going to pick out a dorm. So we know most dorm rooms hold 2 students in each room. You get to your dorm, you go to the RA, and you're like, hey, I'm here. Can you tell me where my room is? They say, listen, you're on the 2nd floor. There's 3 rooms on that floor. Pick whichever room you want. Okay, I don't care which one you pick, but pick one. So you march up to the 2nd floor. You peek into the 1st room. Somebody's already there getting settled. You peek into the 2nd room. Somebody's already there getting settled. You peek into the 3rd room and nobody's there. Which room are you going to choose? Yeah, you're probably going to go in the room that nobody's in yet, okay? If you have a choice, you will go to the room that is unoccupied. You probably won't pull up in a room where somebody's already at. So if there's an option, electrons will go into their own orbital just like you would go into your own dorm room. Now, the next electron or the next person coming to find their room, they see that each of those rooms are occupied. Now we don't have a choice. The very next electron to go into this orbital would have to pair up into one of these rooms, okay? And then the next one, and then the next one. So we would have to pair up if there's no other choice, but if there is a choice, electrons will go into what we call an unpaired orbital, okay? This phenomenon has a rule. It's called Hund's rule. So it's lower in energy for an atom to have unpaired electrons as opposed to paired electrons. So if unpaired is an option, that's exactly what they're going to do. Okay. So let's do one more orbital diagram before we kind of move on. So I want you guys to do the orbital diagram for silicon. So silicon has 14 electrons. So we're going to start and just keep moving our way up. So we're going to go 1, 2, 3, 4. Watch what I do here. Just as a reminder, I would go 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14. Okay. Anytime I'm putting electrons into a p orbital, I go ahead and just put them in as unpaired and then go back and pair them up. Even if I know it's going to be completely full, it's just a trick that I use to remind myself. Unpaired first, then we go back and pair them up. Okay. So orbital diagrams, I like to think of them as our training wheels. This is the first place that we start as we start to get to know how electrons file into place. In the next video, we'll take the training wheels off and we'll talk about something called electron configurations, which is what we as chemists use more often than orbital diagrams. But this was our introduction. I hope you guys found this helpful.